Okay, so what we're going to do today is, this is still like sort of doing, we're going to be using triangles, but then we're going to be setting the scenario up. And they use bearings and they call it navigation because, you know, we're telling you they went a certain direction. So that's called navigation. So we're going to just be using bearings to set up the scenario, and then we'll go and use our triangle formulas that we've been using. All right, so the first one we're going to look at is a true bearing. So a true bearing is an angle measured clockwise from north. So if you have a look here, we've got the compass. Okay, so when you have a true bearing, you start here. So we start at north. Okay, and then you go clockwise. So you move this way. So you move clockwise. Like if your the hands of the clock were moving, you move it around like that. So true bearings are also called three-figure, because when we do a true bearing, we should have 3 digits in the answer. So what we're saying here, so can you see, if we know that that's 90 degrees there, so remember if you've got 2 lines like that, perpendicular, they produce 92. So if this one's 62, I'm going to say you know that this one is 28 degrees. Are you happy with me saying that? Yeah, because it should add up to 90. So if I've started at north and I've gone 28 degrees, then the true bearing for this one will be 028 degrees. Sometimes you see them, they put the T there. True. Okay, so that's a true bearing. So if I was doing a true bearing for this next one, so I would start at north and I'd go all the way around. Now, if we get to, say here, how many degrees in a straight line? Because between north and south is a straight line. How many degrees is there? Do you know? 180. You've got 180. You've got 2 90s, you've got 180. So up to here is 180. And what do we know? What do you think this little bit in here is going to be? Because we know that should be 90 degrees. So what would the next little bit be? 30. Good. So this one's true bearing will be the 180 plus 30, which would give it to be 210 degrees true. So I'll just write that was 180 plus the 30. Okay, so that's a true bearing, and that's what they might use to set up. You'll see it when we do some examples. So, and we only really use true bearings. The only other things you sort of need to know is obviously when you've got your north, south, east and west. So you need to know that in between there, that's 90 degrees. Sometimes it's handy to know if you go from here all the way around there, that's always 270, yeah, because 3 90s is 270, yeah. And if you go the whole way round, if you went the whole way round, you could say that's 360 degrees true, or it could also be 000 degrees true, yeah? So when you're up at north, it can be called 360 or it can be called 0 degrees. All right, so those little things could be handy, and maybe pop in there that one is 180. You know that a straight line's 180. All right, so it just takes a little bit of practice and you'll be fine. These ones are okay. So let's have a go. So let's have a go. A group of bushwalkers leave point P. So here, they're down here at point P, and which runs north and south. So I'm going to draw my own diagram of what they're saying, and they've got their one there. But I want to show you how I would like you to do it when you're doing it. So they say, when you get this starting point and you've got P, what I want you to do is, as soon as you get a starting point, I want you to draw a little, this is where it's good to use pencil, just draw a little dotted compass like that, okay? This is going to help you, and then you go, no, you know that's north, all right? Because they're going to give you a direction. So, and they're saying point P, and it runs along a road that's north-south. So you can see here is the road. Yeah, that's running north and south. That's okay. All right. And they walk for 30 kilometres on a bearing of 20 degrees. So that means they've gone from north and they've gone out 20 degrees. Okay? And then they started at this P and they've walked out 30 kilometres. So that's 30 kilometres. And we know that in there, so really we know down in there is 20 degrees. Okay, until they reached a point called Q. Okay, so then we put that there and we put Q. So what is the shortest distance, and they're calling it X because they've drawn it up in there in the diagram, from Q back to the road, which is the red line. Okay, so can you see you've got a right angle triangle? So if we were doing question A, and just take the triangle out of the scenario so that it's just easy. So you can say, all right, this was P, this was Q, that was 30, there's my right angle, and there's X. All right, so if we were, we also know this is 20 degrees in there. Okay, they want to know X, so, they want to know X, so that would be my opposite side over my hypotenuse side. So which formula would we be using? I'm going to write SOHCAHTOA up here to help us. Which formula has O and H in it? Sine, good. So we're going to say sine angle equals O over H. We're going to substitute in what we know. Sine 20 equals X over 30. And what are we going to do from here? Solve. We can use our solve function, comma X, and we're going to find out what X is. Okay, so did it tell us to one decimal place? So we get X to equal 10.3. And it was kilometres because the measurement was given in kilometres. All right, so we get question B. Looking from point Q, so now we're at point Q, so we're here. I'll draw it in blue. So we're here. What would be the 3 bearing figure to their starting point? So what you need to do is you need to draw your compass. This would be your Q. And what they're asking for is, remember, the 3 bearing, you go from north all the way around to there. Okay? So we need to know, we need to find out what that is. Now we know to here is 180. Maybe what's a way we could find out? I'm just going to call that one Y in there. Because the bearing would equal 180 plus that Y. How could I find out that Y, Alex? Yeah, it is 20. Why do you say it's 20?
Oh, because it's the same angle as the
Yes, good. Oh, yeah, good. Someone said it because it's an alternate angle. So what we've got is we've got see these 2 lines. So this is the road, and I'm going to say this is the north line on the Q, okay? So Q's up here, and P is here. So what we're saying is there's a rule that says if this is 20 degrees, then that's 20 degrees. And someone said it too, they're alternate angles. So we're going to say, all right, that's 20. So we can say the bearing would be 180 plus 20, which would be 200 degrees. You could also had, another way you could have found it is you could have found this one in here, if you like. Yes? And you could have used your SOHCAHTOA if you liked, and then 90 minus that, and then you would have seen it was 20. So there's a couple of ways, but that's okay. That was good. You know, you've remembered your rules from previous years. Okay, a ship left port and sailed east for 5 kilometres. So this is where I'm saying you should, all right, we're going to start off, they're saying this is the port. So because this is where I'm starting, I'm going to draw a little compass. And no, that's north. Okay, and that's the ship. And then now it's ships, so it travelled 5 kilometres east, and then it got to a point, and then, so once you've done one thing, you should then start your new compass. Like, you got a new point, put your little compass on that one, and then do their next direction. And then they then sailed north, so that means they sailed up here. So they sailed north. After some time, an observer at the port, so we're over here at the port, could see the ship on a bearing of 50 degrees. So the port means the person at the port's looking up here. So the ship's up here, it's stopped up here. And the observer's looking at the ship, and they said that it's at a bearing of 50 degrees. So it means you go from the observer's north, so we know that is 50 degrees. All right, so if we know that's 50 degrees, do we know what this one in here is? What would that one be? Why would it be 40? Because 90 minus the 50, good. And we can also see we've created a right angled triangle there. So how far north has the ship sailed? So when they ask that, how far north has the ship sailed? Well, it only sailed north along that bit. So that's going to be X. So I'm going to say X equals how far north. Okay, so so we're looking at question A. So if I just simplify my diagram, I need X. I've got this is 40, and I know this is 5. That means I've got the opposite and the adjacent. So if I write Sokotoa up here, which one has the
10.
Good. So I just write the rule out. Tan angle equals O over A. Write in what I know. I know the angle's 40, X, and 5. And what will I do at this point? Solve. How do we get solve on our calculator? Good, menu 3-1, and we'll work that out. So it's saying to 1 decimal place. So X equaled 4.2 kilometres. Okay, you don't have to write a statement. If you've written X equals how far north, then you should be okay with that. You know, we said that's what it was, so we're happy to keep going. B, looking from the ship, so we're up here at the ship. What would the 3 bearing figure be to the port? So you're going from the ship's north, which would be up there. So this one, I'm going to draw in green. You go all the way around to there. So what's that going to be? What did Alex say the other before? He said if we said if this was 50, doesn't it make that 50?
230.
Yeah. So we're going to say up to here was 180. So we're going to say the bearing was the 180 plus that 50, which someone's saying is 230 degrees.
So this will always be 100.